Applause, please.
Thanks. I strained my voice this past weekend, so I promise you the passion is there. It's just going to sound rather understated. So this is about Facebook's GraphQL server written in Hack, which is a programming language. I know that building a server takes a lot of time. We did that. We spent time and effort into it. So I just wanted to sort of bring some of that back to the community for those of you building servers. And then later, and so for those building servers, I'm going to talk about some of the ways that we've made things work at scale. And then in the second part, I'm going to talk about how we're building our new schema definition system in the programming language Hack going forward. And so for the server developers out there, I'm actually interested in your feedback, thoughts on whether this seems like a good approach, useful approach, that sort of stuff, because we're sort of in the middle of it right now. So first, Hack. What is Hack? Hack is the sort of thing that the word has many meanings. We named our programming language this because we have what we consider a hacker culture at Facebook. But really what Hack is a static typing system for PHP. So a lot of folks have maligned Facebook for being written in PHP. It's like this old backwards language from the 90s or whatever. PHP is a scripting language that lets you write code really fast, that lets things work. It's very effective for a number of reasons. That's why people used it so much. But we built a static typing system on top of it so that it's fully type safe. That typing system is called Hack, and that's open source. You can find that on the internet. And so, and there's an example here, like in this case where you're adding 2 to I and then concatenating it with strings, whatever. Like, who knows what I is when you come in? What is it when you return it? Hack is a static typing system that lets us have a lot better guarantees of what that is. And then HHVM is a VM runtime that does just-in-time compiling for PHP. So when we actually run Facebook, it's run on PHP without all that static typing stuff. So it's like we take these two things, put them together, and our code has far fewer bugs. Believe me. So part of this talk, and since we've developed Hack over the course of the last several years, part of this talk is about like building a type-safe system in PHP to serve GraphQL queries. OK, so part 1 is queries at scale. We have an interesting model for serving queries. This is it. And that's the talk. OK, I'm going to break this down into about 6 different parts. So you got to transport your query over to the server. You got to parse and lex the query. You have to validate the query to make sure that it makes sense to even answer it. You need to defragment, which is to say, like, get all those fragments understood well so that you can put the right information into the response where it belongs. Then you've got to actually get that information to put into the response, and then you have to submit the response. So for transport, so here's an example. This is not actually the newsfeed query. The newsfeed query is a little bit more complicated. But so for transport, the #1 thing we can recommend for transporting queries, especially over mobile devices, is to not do it. The notion of what we call a persisted query means that we take every query that we're going to run on our mobile devices, and we, it's written, and then we save it on our server. At that point, there's an ID number that represents the query, and that's all that needs to get transported back and forth. So this can actually save you a lot of time. There's also some additional benefits to persisting queries that I'll get to later in the talk, like this notion that the device doesn't exactly know what the query is going to be. It just knows what response is going to have. Can have a lot of benefits also. For parsing, we've actually found that writing our own parser saved us a whole lot of CPU. We thought about doing things like just using deserialization or something, like get our AST built, like have our objects that represent objects, all that sort of stuff. But it turned out that parsing every query, when we wrote it the way we expected to, ended up saving a decent amount of time compared to standard JSON parsing and compared to deserialization, having stored those queries, the persisted queries in a database. So I should say, first of all, if you're going to do parsing, you should write your own parser. However, I would also recommend that you not parse if you can avoid it. So one of the cool things about Hack is that Hack is a type-safe system. So we can define what are called shapes. So here we've got a fragment, which has a lot of information, necessary to represent a fragment on a server. But what we do is we represent this fragment as a shape, which is it's basically a magic array, but it's not magic because you've defined what the magic actually is. So when you define a shape like this, it's got a name, it's got a type. But then in the runtime, in HHVM, it's really just an array. And what's the cool thing about arrays in PHP at runtime is that you can cache them. So when I say avoid parsing, what I'm actually talking about us doing is that we take a fully parsed query, and then we just cache the query itself. So we can just access that query whenever we need to. We don't need to parse it. So if you have enough memory to save all of your queries, by all means do so. But we do we take an approach of just caching the top several queries. That saves us a lot of CPU for parsing. Another thing we do is, sorry about the voice, guys. This is really, it's hard to talk. Another thing that we do is we parse fragments on demand. So if we go back to the, can I go back? I'm not, no. So if we go back to this here, we only parse the initial query. And then when we end up at the defragmentation step, where we're taking apart the fragments, figuring out what goes in them, we actually only parse the fragment to figure out what it's about if someone actually calls it. So if you've got your parser system going on there, you don't need to parse what you don't need, which is to say that you can be as lazy as you'd like to be. And then once we've got these shapes that are representing objects of various sorts, they're really just data objects. And so to actually have functioning classes that you want to use, classes that you want to manipulate in order to actually execute queries, hoist those shapes up into objects that do things on demand. So basically, what I'm suggesting is be as lazy as possible. We found that that is very helpful for us. So the next part, and I'm moving a little faster because there's the new definition system that I want to talk about at the end. But if I end up unclear, you can interrupt me and be like, what the hell are you talking about? That's definitely OK. So validation is the question of whether this query can work. And validation is really important because if you have different engineers writing queries, trying to build their mobile app, trying to get something done, then if their query doesn't quite work right, you need to tell them why. So you need to be able to provide a useful error message to engineers who are actually running a query. But you don't actually need to provide those error messages necessarily to the client. So once again, I'm going to recommend that we don't validate. What I'm actually recommending, though, is that there are times to validate and that there are times not to validate. So based on what I was saying earlier, we validate our queries before we persist them. So we've got the query, we've written the query, we've tested the query, lots of error messaging there. It's all internal. It's just some people working on what they're doing. Then we know the query is valid. We know the query works. Persist the query at that point, and then just stop validating it every time you load it. This also gives us an opportunity to normalize the query. So if you've got a query, you can take any query and deconstruct it, reconstruct it on the back end, so long as it's going to do eventually the same thing. And that normalization step allows us to hash the query to make sure we don't persist the same query more than once, right? Because persisting the same query again and again and again would just waste a whole lot of space. And then what we do at runtime is if there's something invalid, we're just like, well, we don't know. So part of the GraphQL spec allows you to distinguish between null meaning the answer is null and null meaning there is no answer. And if you think about it, you can really sort of unroll that conceptually from a programming language standpoint to say, well, there's null, and then there's nothing, and then there's something, but we don't know what it is, and then there's whatever. But we're intentionally avoiding all of this on our server, and we're just saying if something's invalid, then we can't answer, so the answer is null. And the answer of null and not there and error are all sort of mixed together. And then our clients will deal with that. They're like, well, I don't have this answer. What am I going to do? Because for the client, whatever the answer is, they have to make do with that anyway. They can't look to the server. They can't get that information back. So in this way, we're able to actually avoid the notion of something that's invalid by just saying like, all right, no, your implementation of this specific field is not good, so you don't get anything. And then we make do. Defragmentation, I'm not going to suggest that you not do this. I just wanted to call out defragmentation, which is the process of figuring out from which fragment what field you need, translating it back to the type, translating it from the type to the implementation, and then using the implementation to get the data. This is there's a lot of work here, but for a server engineer, this is 90% of what makes GraphQL an API-focused language instead of a database-focused language. So the defragmentation part and all of the work of slogging through the muck to figure out what this query is actually trying to be, what function do I call to actually get the data, is plumbing. And that plumbing is what allows us to actually have a language that makes sense for a client developer to ask questions about a graph using. So don't skimp on this. Also, I mean, society needs plumbers, right? Without plumbers, we wouldn't really have a functioning society. Server engineering, I think, is a lot like plumbing in this way. The other note I just wanted to make here is that as you're doing the defragmentation, you're going to want to memoize everything. You're going to want to say, well, I've got these 4 different pieces of information coming from the same function. We need to put those all together because we're returning the same thing in 6 different places in the query. But as your server serves more and more clients, and here by clients, I mean engineers writing code, as there are more and more people writing code that uses your server, the implementations of the actual fields that they write on their own are going to end up having side effects, right? So you can say something's read-only, but it's not really going to be read-only. There's going to be writes, but the reads are from the app's perspective, and the writes are from the, oh, I just want to log something along the way perspective. That's how it starts out. It starts out with logging. I spent 5 years writing logging APIs before I started working on GraphQL Server, so it's my fault. But now I have to pay for that. So be careful with the memoization. All right, then you gather the data. You actually get the information from whatever your data store is. You can't avoid this. Just returning the same ID whenever someone asks for an ID is actually very fast. If you just return, I mean, I'd recommend 0 if you're going to choose a number to just return. But clients, meaning the apps and the engineers who write the apps, get pretty angry if you do this. Yeah, so the team is motivated by passion, but the rewards for our jobs as engineers is based on performance. The way that we're now achieving fast data gathering is via a really cool code gen system. So we've got our notion of the server, but the server is operating not just on the definitions that the engineers who are exposing a GraphQL object or defining an object that has certain fields do, but we generate code based on those definitions, which the server then uses. And that generated code, do I have pictures of the generated code? No. You'll see it later. But the idea here is that it's not only safer because we can add the hack type safety annotations to any function that we create and then just pull in the definitions that people hand to us, which is actually pretty important because, as you're well aware, Facebook, the company, is older than GraphQL, the language. So we have some really, really old and ancient code that isn't necessarily super type safe. So by grabbing that code and pasting it into a function or into a class or a file that has good type safety, actually gets our GraphQL server to be safer than the code that backs it, which I think is pretty good. And it's faster too, because instead of having to deal with a ton of different objects that you're manipulating, getting the type from the schema, that sort of stuff. You can just directly look at a file which has a name that you understand because you generated the file, and then just accessing stuff directly. And then HHVM, remember I talked about the virtual machine that runs PHP for us, which is also open source, has a notion of an async function. An async function is a function that can get most of its work done, but then eventually it's going to need to hit the database. Hitting a database is something that you can, batch, so to speak. So if I'm asking a lot of questions about a single user, and that user is represented on a single database, I want to make one query to that database. And so HHVM has a really nice system that allows you to just effectively write a function that is supposed to operate asynchronously. So you say you need the result from the function sometime, and then you've got it when you need it. But by building all of this together, we've got a code gen file with a whole lot of async functions that'll just fetch the data when you need. And then for submitting your response, it would be faster to not submit a response to the client. I really, really believe that you're going to start laughing at this joke by the end of the talk. But effectively what we're doing here in order to avoid submitting responses is that notion of keeping null and missing the same, which is to say, since keys take time to ship, anything that we don't need to submit to the client, anything that is null, just doesn't get passed through. So if you make a query on a field and that field is not in the response, we just say straight up, this field is not in the response means that the field is null. So the client's treated as null. And the reason I say keys take time to ship is that the shape that or the struct that you're sending back to the client is going to need to, have keys encoded into it. So if you can just avoid shipping keys and nulls down the, I want to say down the wire, but really it's over the air, then go ahead and do that. Okay, so I'm moving along. This is a pretty fast talk. That's basically a lot of the do's and don'ts for our server implementation, things that we've sort of found along the way. And so I'll take questions about that at the end after I've also talked about the new way that we're actually defining a schema, which I will do now. So what is an object type? Like if you've got a GraphQL object on your server, like how are you actually going to represent the notion of an object? And our old approach was to represent objects using objects. People love to do this sort of thing. And so we created, a PHP object named something like GraphQL object and had people implement it. So it's like if you want to expose a type through GraphQL, write a file that extends GraphQL object, and then we'll collect all those files together later and call it a schema. The downside was this resulted in tons of boilerplate just to reasonably extend the GraphQL object that we defined. So the thing is, like some types, some objects are very simple, some are much more complicated, and the more features we built for people to be able to express different things through GraphQL, the more trouble we ended up in because everyone else had more cognitive overhead in order to understand how to do even a simple thing. So to quote Lee, who's going to talk after me, whenever someone asks for a feature, you just say, we ain't going to need it. And this effectively would have saved us if we had thought of that earlier. It's also hard to mass manage objects. So if people are defining their own GraphQL objects, and there's a ton of different engineers, and some of them have quit, then figuring out what to do with that object when you're trying to update it, when you're trying to figure out what it's actually supposed to mean, because it's named poorly, doesn't have descriptions, that sort of thing. It's really hard with these custom objects. So our new plan is to borrow from the Java annotation system and to say literally any object is a GraphQL object. All you need to do is to say which one. So do I get a pointer with this clicker thing? There's an antenna. There's no laser. All right, no pointer. So in this case, let's say that there's this notion of a Facebook user, and that's just one PHP object, and it represents a Facebook user. To say that this, oh, cool. Does it work? It's got an on-off button that I bet is the laser. Red button. Am I holding it wrong? Does it go this way? Oh, there it is. There it is. I found it. Does it work? There it is. OK. It just doesn't show up on the screen. Awesome. Just, yeah, OK. I ain't going to need it. Thank you. Perfect. So in this implementation, we're actually taking the class of a Facebook user and simply annotating it, saying GraphQL object of user, and the description is a user. And then under the Facebook user class, we've got a bunch of methods on that class. If we want to say that the generate profile picture function is what you call on a user to get a profile picture, then we just annotate that function as being a GraphQL field called profile picture. And in this case, we add an additional annotation to say that profile picture is self-descriptive in exactly the way that users are not. And the key here is that this allows us to actually write a script. Since, remember, we're generating all of this code. This is all code gen code. We write a script that's effectively a build step for a given Facebook class. We just point the script at the class. And using PHP reflection, which is basically like introspection for the programming language itself, you can say, get me this specific class. We look at the class, we look at the attribute, and then we generate the GraphQL code for that specific object based on the specific class that someone passes in. So this lets us just like grab all the information about the class, generate all the information, and create a completely different class that works exactly how we want it to work based on the annotations. So names and descriptions are clearly one benefit of doing this. It's actually amazing how much engineers prefer to explain why something is self-descriptive as opposed to writing a description. Like if we actually made people write a user every time, they'd get very angry at our team. But if we give them something that says self-descriptive, even though it's way more characters, they're much happier to do it. Another note about engineering for engineers, don't use the prefix GQL. It's really hard to type on a QWERTY keyboard. Definitely use the extra letters RAPH. Type isomorphisms via reflection is another really good thing. We've got the ability to go from the Facebook user PHP class to the GraphQL type of user because we can reflect on the class and get the user. And then once we've got a GraphQL type, we can go back from the user types class that we generated, and we know the name of that class because we generated it, back to the Facebook user class. So we actually have this full connection that connects our object types to our PHP types. We also get that via PHP reflection for the return types. So it says awaitable of image. That's because this is an async function. I talked about that earlier. And this is all just in the hack specification. But even for those inputs, if you're sending arguments to your profile picture field, we know what arguments you need, so we can translate back and forth and create additional types and that sort of thing so that all of it is powered via reflection. And we get arguments, we get default values, I just said that. And we get type safety for free from hack. So this is the thing, is that we know that all of the code that's generating the GraphQL responses from the queries is literally the code that we use to generate the responses to the method calls. So we end up with type safety built in from the very beginning. I'll sort of show you how that works. So in this case, we take this definition, and then we'd create a class called GQL user, only because it lets me display the font bigger on the screen for you. Don't name things GQL. That extends our object. And then we've just generated a function that returns a user, which is something that we got out of the user function. And then we've got a get field names function that's going to tell us what field names are there so that we can power GraphQL introspection correctly. And we can do the same thing for GraphQL field descriptions. We're just generating these classes directly. Then separately, we generate the methods. And the cool thing about the methods is we can write a method that takes a literal Facebook user object in, as well as the arguments. And we've code-generated a specific type representing the arguments to the user function. And then we can use that definition to only process the arguments that we need to at runtime. So this is where we're gaining all of that extra speed. By running profile picture directly like this, we're effectively being as thin of a layer on top of the PHP code as we possibly can be. For type introspection, we just generate a new function or a new method for our generated class that ends with type that just returns the type. And of course, the type is something that we get from the definition as well, because if we're annotating a getProfilePicture method as being the profile picture field, we can look at the return type image and go directly to what GraphQL type is represented by the image. Then in the code generation step, we can just generate that code to have it. So at this point, you just grab your image right from there. We know it's an image. We know what that's represented in GraphQL and PHP because we have that isomorphism. And then the result is when we want to get results for a specific type, when we want to just figure out what fields we want, it's like 6 lines of code. And it's extremely simple. If you know how to use, if you know hack code, then this looks very simple to you. But the key here is that PHP has a system that lets you just call strings as methods, and that lets you create classes from strings. So here we have new type name. New type name is basically just saying we literally know what the type name is based on the GraphQL type because we generated that class. And then we can just instantiate one of those classes for free, just right there, and then call a method on it that we know exists because we generated all the code to promise that it exists, which is extremely fast. And then we just call that function right there. We don't even need to know what the function is. At runtime, we concatenate strings in order to get the right thing the first time. This is not type safe. So the hack type checker doesn't know what that string is in all possible cases, given that a lot of that information is coming in as part of the query. But it's been, so it's not type checked, but it is type safe because we use this generation system to cobble everything together. There's a literal file sitting there representing a class with full type safety that does everything we need it to do. And since the runtime's not going to pay attention to any of the type annotations anyway, it's just a PHP executor, we literally don't need to know. So that's the idea. GraphQL interfaces are just as simple. We can take a PHP interface, and then we can say it's a GraphQL interface. And then later, when we've annotated Facebook user as a GraphQL object called user, we use PHP reflection again to look at the interfaces. And if any of those interfaces are GraphQL interfaces, we just know that the user type represents the IGQL agent GraphQL interface, right? So we just pull this directly out of the code. All we need is that one annotation, thanks to the way that PHP gives us information about PHP. Traits are super cool too, because in PHP you can just say, here's my trait. If you annotate a function in a trait, then you use the function in a class. When we reflect on the class to get its methods, if the methods are annotated, we know that they're fields. But in the classes that import the trait that aren't annotated as being types, you just never look at the annotation. So it just works all the time. And it means whenever someone adds a trait that they're using, they've automatically exposed through GraphQL everything that they already said they wanted to expose through GraphQL. And this actually can solve a lot of problems that you'll find if you end up having multiple schemas. I would generally speaking recommend against having multiple schemas. Like really just one schema is all you're going to need. It's faster if you have 0 schemas. So I mean, maybe you're not going to need it, in which case you've wasted a couple hours tonight. But if you've got a few different schemas that are fairly closely related to each other, you're going to want to end up reusing code. Code reuse, I think we're still agreeing that's a good thing. So the trait annotations can matter or they don't. You just annotate something and say, if you're importing this and exposing it via GraphQL, then you can just slap on the trait. So that's it. Actually, that's actually it. Got one question already. Is all the swag gone? Do I hand these out to people? Who's in charge? This guy raised his hand first.
Okay. So, well, thank you for the talk. It was awesome. Thanks for that. And now we have 3 swag we can share. So
Okay.
What was the question? I missed it.
It's this guy here.
Okay.
The first person who realized I wasn't joking about the talk being over in only 30 minutes.
So first thing, really cool. I mean, how you can just make so many things redundant in first place. Closer, okay. So why do you need to use like hack in first place if you can just let everything go and and you have so many resources in Facebook to kind of
I mean, there is a time in every Facebook engineer's life when they say to themselves, why? Why, Mark? Why PHP? But it seemed like a good idea at first, and then it seemed like a fine idea until it was too late to just rewrite the site in Python. So Facebook started as a website. I know that now people understand it to be a mobile app, but it started as a website written in PHP because PHP is a web scripting language. And so the website is implemented there. All of our infrastructure is in PHP to make the website work. So the reason that we back our GraphQL queries with PHP is that all the stuff's already there. Like all of our infrastructure, it's connected to the databases. People are used to writing the code. And it means that anyone who's developing for the website is accidentally developing for the mobile site. All they need is a mobile engineer to slap an annotation onto a type. Well, yeah, thousands and thousands of PHP developers. I mean, like, really, I'm saying that we started with PHP and then we invested so much into it that the cost of switching to a new language at this point is way too much. Like, even though some of us would like to have it written in Python, others want it written in Haskell. Some of them want it written in C++. Like, everyone has their other second favorite language. And like, just getting us to agree on it would take years. Oh, this guy's got a microphone, sorry.
Sorry, 3-part question.
Okay.
You mentioned writing your own parser, but Facebook actually publishes a C parser that they're encouraging people to use. You're not using that internally? And/or do you not encourage people to use it?
So, I mean, a query comes in. We have to parse the query.
Right.
And so...
There's like a libGraphQL parser. It's like a Facebook C parser for GraphQL and GraphQL schemas.
Yeah, I mean, if you're using C...
Well, no, you can write extensions for any language.
Yeah.
It doesn't matter.
I mean, basically, reading each thing and then just knowing what something is and then having it right at that moment, it's already parsed directly into the shape. The shape is what we then cache. Faster. Just faster.
Cool.
I mean, that parser I'm certain is going to work, and it's going to do a good job. And if your goal is to have something that works, by all means use something that works, right? The Apollo team likes this philosophy. Don't build a server, right? But I mean, like, we care a lot about performance, and so this was a little bit faster, and so we did it this way.
So you mentioned like all the tooling and using a weight to kind of batch stuff, but are you guys doing any more to actually like optimize your queries, like considering like joining databases and whatnot? Like, do you guys have a approach to that, and can you share or?
So the GraphQL server team specifically is trying to be as thin of a layer as possible. So that's a great question for like, how does Facebook answer a web query? But that's sort of beyond the scope of this talk and my knowledge.
Trying to reach the guy.
Hey, thanks for the talk. That was awesome. I work at Twitter, and we did the other thing where we were like, it's Ruby, and then rewrote it. So if people want to hear about the other side of that, then I can tell you about it.
How'd that go?
Yeah. I'm a front-end engineer. I got nothing to do with it. So my question was about the distinction between the shape of these objects on the server side and the shape that the client wants them to be. And seems to me GraphQL is a technology about building clients, and I wondered how you deal with the situation where the object as represented on the server would be inefficient or uninteresting for client engineers, and you might want a different shape using your annotation system, or if you just don't use it for that and instead you keep your existing objects.
I mean, we have a lot of different ways to get the data from the server to the client, but at the end of the day, like how we represent it on the server, it's going to need to be translated into something that the client can read. So once you've got your data, you're going to need to like put it into, or you're going to need to serialize it somehow in order to get it to the client. So I mean, for the server versus the clients, like we do a whole lot of code generation so that the clients just have access to an infrastructure that's given to them by the server. So it's actually really easy for them to just use it. Yeah, I'm just going to keep hitting the code gen hammer and just say generate more code. We've released a code gen library. It's also open sourced for code generation.
I'm sorry, I probably phrased the question wrong. The example I would think of is, let's say that getting someone's friends is a method on the user. Or actually, let's say it's not a method on the user and it's a method on your graph store. Right. But you want to represent it on the user object and use your connections and node stuff.
Exactly.
How do you wrangle that? Great question.
Great question. The answer is to write a function that does that. I'm sorry, that was rude of me. I'm naturally rude. I'm American. But like this was actually one of the big things that we fought about, me and the one other guy on the GraphQL server team, who's giving this talk in 2 days in San Francisco at a meetup. There's lots of meetups. But it's like, well, what if we don't want that function? What if that function is the wrong function? And then it's like, well, we'll just write another function because we'd need to write another function, right? Like if we've got a graph store that has some way to say, get friends, then chances are that class that you have that's supposed to represent a user is going to need to call that function in order to return the friends, or you'll call some other function some other place. But if you're calling that other function in that other place, then you may as well just put it into a trait, and then you're done. And this is actually one of the answers to a lot of different questions along the same lines, which is, well, what if you want to change your class? What if you want to develop differently for the GraphQL exposed versions than the PHP functions that you're actually using? Create another class. Just make another class that's a thin wrapper, and you are strictly no worse than us forcing you to write an entire class that extends GraphQL object.
Cool, thank you.